Welcome to Maths for Each channel, a past question on application of differentiation from Sri Lankan A-level past paper. The adjoining figure shows a basin in the form of a frustum of a right circular cone with a bottom. The slant length of the basin is 30 centimeter and the radius of the upper circular edge is twice the radius of the bottom. The radius of the bottom be r centimeter shows that the volume centimeter cube of the basin is given by V equal 7/3 pi r squared times square root of 900 minus r squared. R is greater than 0, less than 30. Find the volume of the R such the volume of the basin is maximum. Okay, I have resketched the diagram given. Is the frustum, or in other words, is the bottom section of a cone. 2r is the radius, the large radius is 2r, the small radius r, and 30 slant, the distance is 30 centimeter. I have sketched the complete cone. Its height, call it h, and r and 2r. If you could imagine that the rectangular triangle there, and r and 2r, so it's twice as much as the smaller rectangle, the large rectangle, so it's right in the middle. So the bottom slant length is 32nd, and the top slant length is 32nd too. So it just sort of cut the half of the top off. So h is her whole height. So the top, or in other words, the bottom cone is half too, or bottom and top is half each other, the height. A standard equation for cone volume is V equal 1/3 pi r squared h. I call it the complete cone is the large cone, big cone, with the radius 2r, VL equal 4/3 pi r squared h. How that comes up, radius of that cone is 2r. So we know by 1/3 pi r squared h. R is 2r, so it's 2r squared is 4r squared. So that is why 4/3 pi r squared h. H is the, we don't know, just call it as h. And the smaller cone, which is the bottom cone, again, the h is half and the radius r. So 1/3 pi r squared h is half of h. So 1/3 pi r squared h over 2. If we could do that, then pi r squared h and 1/6 of pi r squared h. That's the small cone. The frustum is the big cone minus small cone will give us the frustum. And as I said, that we can take that the rectangle triangle, the big rectangle triangle from the top to bottom. The bottom is 2r, the height is h, and the slant distance 30, 60 centimeter. From that rectangle triangle, we can use the Pythagoras. 4r squared plus h squared equals 60. We need to use it later on. I just want the Pythagoras, just keep it that way. But VL is 4/3 pi r squared h. But that is, well, I just they make the denominator same as the small volume Vs because of 1/6 pi r squared. So I just want to make that. So in other words, multiply top and bottom by 2. So 4 multiplied by 2, 8. 3 multiplied by 2, 6. So just make the denominator or LCM same. 8/6 pi r squared h. And the small one is 1/6 pi r squared h. One from the other give us the frustum. So the volume of the frustum is 8/6 pi r squared h minus 1/6 pi r squared h. The denominator same, so the LCM same, just 8 minus 1, 7/6 pi r squared h. Right, the h is the one we introduced, so we need to eliminate that. From 1, the Pythagoras we just had, that from that, simply it's just h squared equal, take the minus, take the 4 us the other side, right hand side. 60 times 60 is 3,600 minus 4r squared. Just take 4 out, and h is square root of plus or minus, but no minus business, just plus because it's a distance, height is a positive value. So take 4 out outside the root sign, that is 2. So 2 and 3,600 divided by 4 is 900 minus r squared. So h is twice 2 times square root of 900 minus r squared. And substitute that, Vf, the volume of frustum, equal 7/6 pi r squared. And the h is, we can replace with 2 times square root of 900 minus r squared. From that, simply is a 2 there. So if we could do that, that will be 3. So 7/3 pi r squared, square root of 900 minus r squared. This is exactly what we have been asked to prove, which we have done. Right, the volume of the frustum is, we just proved it in the form of r. So r is a variable. They ask what the value of r if it's maximum, if it's reached maximum. So we know that maximum minimum is, we need to differentiate equal to 0. That gives us the radius. And okay, v equals 7/3 pi r squared. And I just put 900 minus r squared to the power half into easier to differentiate. So we need to differentiate with respect to r. The r is the variable. So dv over dv, v is the variable too at this stage. So when r change, v change. So dv over dr equal 7/3 pi, just constant, and u into v form. So r squared times differentiation of 900 minus r squared to the power half. So half times 900 minus r squared to the power of half, minus half, because of half minus 1 is minus half. Then minus r squared, differentiation of minus r squared is minus 2r. That is this one. And then plus 900 minus r squared to the power half, then differentiation of r squared, which is 2r. So rearranging it, simplified, 7/3 pi is the same. And this 2 cancelled out, minus there, minus r, and minus r squared here, so minus r cubed, and 900 minus r squared to the power of minus half, plus 2r, 900 minus r squared to the power of half. We know at the turning point, this maximum minimum, is dv over dr equal 0. Therefore, minus r cubed, we can just ignore that 7/3 pi because it's a constant and it's a value. So all we have to consider minus r cubed times 900 minus r squared to the power minus half, plus 2r 900 minus r squared to the power half equal 0. If you could rearrange it, minus half, I would make it minus r cubed over square root of 900 minus r squared plus 2r times 900 minus r squared. So r squared, 900 square root of 900 minus r squared is an LCM. If we take that, here on this first one, just minus r cubed. The second one, 2r times 900 minus r squared, because of root of 900 minus r squared, another root 900 minus r squared become just root removed, 900 minus r squared. So that is equal 0. And then the denominator, ignore it. What we have, r cubed plus 2r times 900 minus r squared equals 0. And if I could take r out, and minus r squared plus 2 times 900 minus r squared equals 0. R cannot be 0, so what can be 0? Minus r squared plus 2 times 900, 1800, 2 times r squared, minus r squared, minus 2r squared. And if I could make it minus r squared, minus 2r squared, minus 3r squared, 1800. If we could take the other side, or multiply by minus what you get is 3r squared. Instead of minus 3r squared, it's 3r squared. Plus 1800 become 1008 minus 1800. Take the 800, 1800 other side. 3r squared equal 1800, r squared equal 600. Therefore, r equal plus or minus, there's no minus because of the distance, a positive value. There's 10 because of, you can write that 600 equal 100 times 6. So 100, square root of 100 is 10, square root of 6 is square root of 6. That is centimeter. So this is the only value. And we can prove, but we don't need to prove it's maximum. The basin such that the maximum, if you want, we can prove it's a maximum. If you want to, we have to go to the second order differentiation, but it says that maximum, so we just took it as the only value we have. So obviously, this is the maximum volume. R is 10 root 6 for maximum volume. Thank you. Please subscribe the channel and share the contents with your friends and other students. Thank you.